Hi, today we're going to just do dividing monomials by monomials. Remember when we're doing the monomials, that division bar reminds us of a minus sign. Okay, so at the very bottom, I'm reminding you what happens to our exponents when we have variables. With exponents, we subtract them. And that, as I said, that division bar is going to remind us that we're supposed to be subtracting those exponents. So we have m to the 10th divided by m to the 5th. So we subtract those exponents. I always look at which exponent is the larger of the two, and that's where I'm going to start my subtraction. So 10 minus 5 would be 5. So m to the 5th over 1, because that would cancel out at the bottom. Do I have to write the over 1? No, I do not. I can just write m to the 5th. Okay, on to the next one. 4 raised to the power of 4 divided by 4 raised to the power of negative 3. Remember, if it's negative, it doesn't like where it's at, so we have to move it to the top. So, if we move it to the top, then we're left with 1 on the bottom, and 4 to the 4th times 4 to the 3rd. It is now happy, so it's positive. And now we are not dividing anymore, we're multiplying. And remember, when we multiply, we add exponents. So that means those exponents are going to be added, and we're going to get 4 to the 7th power. It does not have to be over 1, so we can just write 4 to the 7th. Let's go down to the bottom. We have p to the negative 7th divided by p to the negative 5th. Remember, when it's negative, they don't like where they're at. So we're going to have to switch them. So I would rewrite this, p to the 5th divided by p to the 7th. Now, we're going to subtract those exponents. I look where the larger exponent is because I have more of them, and I have more of them on the bottom. So I'm going to subtract from the bottom. So 7 minus 5, because that's going to leave me 2 p's on the bottom. So p to the 2nd. And that leaves me a 1 on top. Do I have to leave the 1 on this one? I do, because it's a fraction. So it would be 1 over p to the 2nd. Let's go to the next one. We have 6 r to the 4th divided by 9r. Now remember that r does have an exponent. We don't see it, but we know that there's really a 1 there. So we have to remember that there is a 1 there. So 6 to the 9th, let's do the coefficients first. All we can do right there is reduce. So let's reduce both by 3, and we'll get 2/3. Then let's look r to the 4th, r to the 1st. They're both r's. Look at their exponents, 4 over 1. So we know we have to subtract the exponents. Look at the larger. It's on top, so it's 4 minus 1. And that leaves us with 3 on top. We are done. Let's try some more. This one's a little bit bigger, but that's okay. I always draw my line first to get started. So 48 on top, 12 on bottom. I know that 12 goes into 48 4 times. Left with 1 on bottom. A to the 3rd, a to the 5th. The bigger number is on bottom, and so I'm going to do 5 minus 3. And I'm left with 2. So a on the top cancels out. I'm left with 2 down here at the bottom. B to the 1st. Don't forget that there really is 1 there, and b to the 3rd. The 3 is the bigger number, so I'm going to subtract from the bottom. 3 minus 1. So I'm left with b to the second. Now we have c to the fifth divided by c to the second. The 5 is on top, so I'm going to subtract from the top. 5 minus 2. So I'm left with a c. Make that into a c, sorry guys, to the third. I didn't need that long of a bar, but that's okay. Let's try another one. I'm looking at the very first. I do the numbers first, and so I have 14 divided by 21. I can divide 7 out of each of those, and I'll be left with 2 over 3. My poor little line got a little crooked. Then I have j, and since I don't see, I know that there's still a 1 there. So j to the first divided by j to the fourth. The bigger number's on bottom, so I'm going to do 4 minus 1. And that would be 3. So I'm left with j to the third. K to the second divided by k to the fifth. The bigger number's on bottom. So I'm going to subtract from the bottom. 5 minus 2. That leaves me with 3 k's. So the answer would be 2 divided by 3, j to the third, k to the third. And remember, if you ever have questions, you can always expand it out and then cancel out to find the same answers. We'll do one more. (12) over 3. We always start with our coefficients. 3 goes into 12 4 times. And for right now, I'll go ahead and put the 1 on the bottom. Then I have x to the sixth, x to the second. So the bigger number's on top, 6 minus 2. And I know that's 4. So I have x to the fourth left on top. Then I have y to the negative fourth and y to the sixth. Well, I know that I have to move those because they're negative. They don't like where they're at. So it's going to be y to the sixth. And continue that bar, and y to the fourth. And I do that so I don't get confused where they're supposed to be. So now I can go in and do y to the sixth, y to the fourth, the bigger numbers on top, so 6 minus 4. And that would be 2. So I have y to the second. Now I go to my z's. I have z squared divided by z to the third, the bigger numbers on bottom, so 3 minus 2. And that leaves me with 1z. And that would be your answer. I hope this was helpful. Monomials divided by monomials. Have a great day.